In this session, we will see about half subtractor. A half subtractor is a device which accepts two input and produces two output. First, we will draw the logic symbol of half subtractor. So we will see the logic symbol. So when we draw the logic symbol, so we will mark only the inputs and outputs. We have two inputs A and B, and this is the half subtractor, and we have two outputs, the difference, D stands for difference, and we have a borrow, B, and it stands for borrow. So this is the logic symbol for half adder. Next we will see the truth table. We already know a truth table is a table which shows the relationship between input and output. Here the inputs are A and B, and the outputs are the difference and borrow. So we will see first A can be 0, B can be 0. Then A can be 0, B can be 1. A can be 1, B can be 0, and A can be 1, B can be 1. So these are the four combinations. So first we will see the case number 1, that is A0, B0. So if we subtract 0 and 0, we will get the difference 0 and borrow 0. What about 0 minus 1? Smaller number minus larger number. Yes, we can subtract, but we will take a borrow from the previous number, previous bit position. For example, in decimal number system, 1, 6 minus 8. What will we do? We will borrow this 1 and make this as 16. Then we will do 16 minus 8 is 8. So we borrow a bit from the next position. So similarly, if we subtract a smaller number from the larger number, we need a borrow. So whenever we see 0 minus 1, in the binary case only 0 and 1 are there. So whenever we see the case like 0 minus 1, put a borrow, because without borrow you cannot subtract, because 0 is smaller and 1 is larger. So 0 minus 1, the difference is 1. The difference is 1 with a borrow 1. Now 1 minus 0, yeah, difference is 1. Actually there is no need of borrow. And 1 minus 1, difference 0, borrow 0. This is the truth table. And now we will see the logic expression. Logic expression, or it is also known as logic equation. So we need to find the expression for difference and borrow. What is difference and what is borrow? First we will see the difference, the equation for difference. So that is D is equal to. So we can see D is 1. D is 1 in this case and in this case. You can see here D is 1 in these two cases. So that is, the first case is D is 1 when A is 0 and B is 1. That is when A is 0, that is A bar B, and B is 1. That's why I have used multiplication, A bar and B, that is 0, 1. Or the second condition. So or means plus. Or the second condition where D is 1 is A1 and B0, that is A into B bar. So this is difference, and you already know this is the equation for XOR gate, and therefore this is the equation for D. This is the equation for D, difference in half adder. Next we want to see the equation for borrow. So here you can see the borrow is 1 only for one condition. So that is borrow is 1 for this condition, that is A is 0 and B is 1, only for one condition. So we can write borrow as A bar B, that is A0 and B1. So this is the equation for borrow. So these are the two equations of half adder, or we can say it is the logic expression for half adder, the logic expression for half adder, difference and borrow. Now we can draw the logic diagram. Logic diagram. So logic diagram is the diagram drawn with the help of logic gates. So we have two inputs. First one is A and the second one is B. These are the two inputs. So first we will find D. What is D? D is A XOR B. So we want to XOR A and B. So we will draw the XOR gate. Sorry. So this is XOR gate and this is D, that is equal to A XOR B. And now what is borrow? Borrow is A bar B. So we want to take this A and invert it. Now this is A bar, and now take this B. We need to multiply both these. So this is A bar multiplied by B. That's why I have used AND gate. AND gate is, it will multiply the inputs, is A bar B, or we can write it as the borrow, that is B, is equal to A bar B. So this is the logic diagram. So in a half adder, first, sorry, it is not half adder, half subtractor. In a half subtractor, first we have the logic symbol, then we have to write the truth table, then derive the logic expression from the truth table, and using that logic expression finally draw the logic diagram.